Hi everybody, I'm JJ and you're watching content from securityuncorked.com. Continuing our Zero Trust conversation, I'm going to talk about the Zero Trust product suites and enforcement mechanisms in those products. So if you followed along with the last video, there's a couple of things you've seen here with the lingo. Go back and maybe revisit that short video if you haven't seen this. I'm going to hit just a couple of highlights here because it's going to be relevant when we get to the enforcement matrix. So again, there's a policy engine up here, and I have to switch back to the screen. So policy engine up here, which is making the decisions about what is or is not allowed access to what else. It may also participate in the brokering of that access. And then we have the different policy enforcement points, and these are the little red little boxes you see right there. So those are the pieces of software or pieces of hardware that are actually the mechanism by which that access or lack of access is controlled. And that could be doing other things like traffic inspection, adding encryption, or stitching together different tunnels for that remote access. So policy engines, policy enforcement points, those are the important things to know for right now. The last video talked through the three models of the access or the use cases for Zero Trust. That was user to resource, meaning a person on a device trying to access something, and that resource could be on-prem or remote. We had device to device, which is where the network-based microsegmentation came into play. And then we had service to service, which was that, more data center workload protection conversation. So the first thing to know is that right now, every vendor is going to pitch everything to you as a Zero Trust product. So my friends at CISO Talk and TechStrong put this together because on one of the panels we were on a few weeks ago, I made a comment about a Zero Trust oven, toaster oven, because everybody has a Zero Trust product. Doesn't matter what it is. Is it a switch is now a Zero Trust product. Every endpoint agent is a Zero Trust product. I feel like the trash cans are Zero Trust products now. So you have to be a little bit careful there. What I want to kind of talk about is this landscape of product suites. So very high level here. These are probably a lot of the acronyms that you see. So I'm going to start with the big one in the middle, and that's ZTNA, which is Zero Trust Network Access. And we talk about how Zero Trust is not a product. It's not even a product set. It's a concept, etc. ZTNA, though, is the one sort of exception to that. So ZTNA is a kind of a dark cloud model, or what I call lights out model. The idea is it's based on the Cloud Security Alliance software-defined perimeter specifications. And what we're aiming for in a ZTNA architecture is passers-by. So I always use the analogy that there's a dark winding road out in the country and there's a lot of trees. So at night, ideally in a ZTNA architecture, somebody's going to be driving down that road and they're not going to know that any houses exist. They're not going to see anything. They're not going to see any lights. They're not going to see driveways or mailboxes. Compare that to what we have now, which would be if you have remote services, you have all sorts of things in the environment that point to the fact that you have remote access into that, or you have applications and resources accessible different places, whether it's on-prem and you've got firewall policies and a DMZ, or it's infrastructure or platform as a service architectures that are in the cloud. You've got all sorts of things like public DNS entries and pointers that are sort of those driveways, mailboxes, and lights that indicate what those paths are into the house, as the analogy goes. So things that follow ZTNA principles are obscuring that visibility from the outside, and not obscuring in a bad way as in like security by obscurity, but they're removing that visibility. And so only that ZTNA architecture can connect to the resource, and then it makes the decision about that user or the requester that's trying to get access. And that's where that policy engine comes in. Is this person or is this device allowed? What are the conditions around it? Whether it's, conditions on the internet, threat intel feeds, conditions on the requester, like posturing for an endpoint, or conditions in wherever that resource is located. Maybe it's missing a patch, or there's some vulnerability or known immediate attack for that platform. So the ZTNA is going to make that decision of, okay, here you're requesting this access. We have access to this resource, and we're going to then sort of broker that access. So I, as a user, wouldn't have direct access to that resource. I have to go through that ZTNA architecture to get to it. So that's what the world of ZTNA is. It's a pretty big bubble. A lot of stuff can fall into that. And it has a pretty big overlap with the SASE architectures. And so both of these things are going to be very heavy in this cloud routed, cloud native architecture. And I'll talk about SASE and the way that overlays with points of presence on a different talk. It'll make today too long. So we'll get back to that. Then we've got things like Secure Web Gateway, where we're sort of taking the enterprise security components, features, architectures that we would have on a traditional campus, and we're trying to wrap that around an endpoint or a user that's traveling around off-prem. So that's all kind of similar. CASB with that cloud access brokering is similar. And then, of course, the big other bubble down here is EDR, which is endpoint detection and response. And so it's probably pretty clear from those descriptions that all of these things, and I'll lump them together visually for you, all of these things really fall into that user to resource access mode we talked about before in a previous video. So what does that leave? Now, a little bit of that can sort of float over into the SD-WAN solutions. There is quite a bit of overlap with some of the SD-WAN solutions and a lot of the SASE architectures, but they don't have to be, right? You can have them separate. And then we get into the device-to-device access model, which, terrible handwriting as always, I apologize, which is obviously everything related into the network segmentation and network microsegmentation area and bubble over here. It can also play a little bit of role within the SD-WAN architectures too. So we can certainly use SD-WAN architectures to extend network segmentation for things like IoT devices and OT devices beyond the traditional LAN borders. And then that leaves workload segmentation over here in this little lonely bubble. And that is that server to server or service to service, microservice to microservice, microsegmentation that we've talked about before. So those are your three use cases here. As we described them earlier, there's number 1, number 2 with device to device in those bubbles, and number 3 over here. Now, the reason that they're broken up like that, and the reason, as we talked about in the prior video, that a lot of times the products don't cross between these borders, here's why. It's because of the enforcement mechanisms. So the enforcement mechanism, if you think back, well, I can just scroll back. If we scroll back to this picture where we have the diagram of those policy enforcement points and that policy engine, it really comes down to these policy enforcement points. So when we come back down here, we have 2 primary ways we could implement an enforcement point. It can be software-based, like an agent. And with that, I'm going to go ahead and lump in the things that operate like a dissolvable agent that aren't necessarily persistent. So software sort of agent-based, or it can be an appliance, and the appliance can be virtual or it can be physical. And so let's break this down a little bit further. When we get into the software types here, and that's the first part of this table up here, the enforcement model can be a few different ways. So I mentioned there's agents. There can be an agent on the resource, meaning the thing we're trying to access, that server, wherever it may be, on-prem or in the cloud, or in that enclave model, maybe it's a whole group of resources. Same thing with on-prem. It could be an agent on the requester. So me as the user with my device may have an agent on it also. It can be agentless on the requester, meaning so perhaps in like a contractor or a BYOD model, maybe my endpoint as the user doesn't have to have an agent on it. It has some other mechanism to connect that's not persistent. And then some combinations of the above. And the ellipses here, because this matrix is always sort of in flux and changing and growing as this industry changes and grows, because it's very volatile right now. Everything's just all over the place. But the policy enforcement type of software is we have some type of software agent that's controlling this access. which means we have to be able to install that software agent on something. So most often these solutions are designed to support traditional operating systems. And that mileage, of course, varies with the vendor and the product you select. So some sort of cover all of the bases with traditional laptop operating systems, as well as things like smartphones and Linux. And then you'll get others that have just a subset of those that they're supporting. So that's all of the enforcement models for the software. Let's continue the conversation, or actually let's talk about the enforcement mechanism. So if we're doing this with software, we're going to be doing it one of a few different ways. And again, ellipses, because this is always changing. The vendors are coming up with sort of new and innovative, creative ways to do this. But traditionally, that's going to be DNS. It could be a local firewall on one end or the other. Firewall isn't a host firewall. Local routing control that's happening in the agent at the software level, or external routing, where kind of that ZTNA model where there's sort of this pretend there's a tunnel between the resource we're accessing and the ZTNA cloud or brain, and then me as the user up to that ZTNA cloud or brain. And perhaps it's that ZTNA or SASE cloud that's then handling the routing. So that's sort of an external routing control. And then we get into what is that level of granularity we can get based on the enforcement mechanism. So you see a list of things here: TCP and UDP ports, application signatures, microservices, etc. And then the conversation as we get into some of the nitty-gritty details about these different solutions is, is it encrypted, and is it unidirectional or bidirectional from the standpoint of initiating that connection. So, obviously most can do you need to do bidirectional when you're doing TCP, but not all products can initiate in each direction. They may only be unidirectional from that initiation standpoint. So that's the world of software enforcement points. Let's look at the world of hardware or appliance-based enforcement points, which again could be a physical appliance, a piece of hardware, or it could be something that's virtualized. And now we get into the enforcement models and mechanisms that are a little more common to us from the network infrastructure, network security side. So we have things like firewalls, switches and routers, gateways and SD-WAN, appliances, micro gateways, wireless controllers, and the things that fall into that category, and then some vendor specific things here. And so when we look at things like firewall or switch and router vendor and those sorts of things, when we're talking about a zero trust architecture or a zero trust implementation, it may be that that's not just your regular firewall you've been using for the past 5 or 10 years. This is probably going to be a newer model, something with additional intelligence built into it, and certainly some additional mechanisms such as APIs to connect to that policy engine, whatever it is or whatever they are, so that it has a mechanism to communicate and you're not stuck with vendor lock-in there. So that's an emerging market at this point, but we're heading down that path. A micro gateway operates as, the marketing materials for these are pretty cool, but effectively it sounds very simple when you think about the implementation, which is you kind of drop something in, you can point different networks to it, it's going to serve DNS and DHCP, it's going to issue, basically a /30, and that micro gateway is the default gateway of everything you've pointed to it. And so it's going to make the decision about what that thing and each of those things can get to. So it kind of aggregates all of that into one place. It obviously doesn't take into account, user metrics or posturing or anything like that we might have from a software agent. But it is a really neat way to sort of do that quick, down and dirty, get from point A to point B in a network-based microsegmentation very quickly. And then all of the other stuff related to Wi-Fi, which can operate like a switch router or firewall. So all of your enforcement mechanisms are the stuff that are just typical and traditional for network architectures, right? Things like VLANs, other network virtualization functions like VRFs. We may have different firewall policies or zones that are dynamically controlled. And then your assortments of, VLANs and ACLs. So I think it's probably, if you've been a network engineer and you've done anything in the networking world, it's probably apparent at this point that obviously these things down here are going to be the only choice if you want device to device control. They can also do user to resource control in some instances, since there's some overlap there with some of these products. But you don't really have the option to install software agents on a lot of these devices, such as IoT and some of the OT devices. And so this is going to be your primary solution set for that user to resource model. Again, with a little bit of overlap down there if you want to do some stuff on-prem. And that is why the product sets don't really overlap very much. The software-based solutions, most of them were born out of very cloud-native, cloud-routed vendors. And so they work very well when the user and the resource are not co-located. So remote user, remote resource, something in the cloud. Whereas all of the stuff down in that traditional sort of networking and appliance side is more tuned for that campus LAN sort of architecture. So hope that clears up why some of these products and some of these different solutions are like more or less appropriate for these different use cases. We talked about the 3 use cases. Go revisit that video and stay tuned for more content from Security Uncorked.